Hi folks, Mr. Long here. Just going to do a quick screencast on the idea of absolute extrema. So we have absolute extrema or extremums, and we have relative or local maximums and minimums. So this is another thing that this is called is an interval test. So all we're looking for when we're doing extrema is, by extrema we mean extreme values, so maximums or minimums, and we're trying to find what's the highest point on the graph and the lowest point on the graph in an interval. So in this question it says, given this graph, okay, given this red graph of f at x below, what are the absolute extrema in the interval -6, 2? So in other words, if I look at all the y values starting at x equals -6, which is right here, and I ride the curve up and down, what are the lowest and highest y values? So if we notice, I can do this really easily when I have the graph. I know there's my lowest point right there. Okay, and that's going to be, you can't really probably see the scale here, but that's at about -0.5 there at 2. And then what's the highest point on the graph? Well, it's right there. It's at, and that's about 1.4. Okay, so just by looking at the graph, I can see the place where it reached the highest and the place where it reached the lowest. Now, how do we go about doing that? Okay, how do we go about doing that? So what we do is, there's possible locations. Possible locations for maximums and minimums are always when the slope is 0, or you're going to find out in the next few days when the slope is undefined as well. But so right here, the slope is 0. So if there's 0 slope, there's a good chance there's a maximum or minimum right there. Now we call these local because a local maximum just means that the graph turns, it goes up, goes down. So locally, that's a maximum point. It doesn't mean it can go higher somewhere else like it does in this case, right? So that's a local maximum or minimum when you get a horizontal tangent like this. And there's what you have is a turning point, right? It turns from going down to going up. But of course, you also have to check your endpoints too, because it might be that your endpoint is actually lower than all the other points on your graph. So what's the definition? So the function f has an absolute maximum at c. That means the x value of c. If, when I sub in c to f, it's greater than all the other y values. So if we look at this, if I was to sub in x equals 1 into this graph, if I had an equation, I would end up with a y value that's bigger than any other y value in that interval from -6 to 2. So if I put this in here, I'm just going to type that in. Now, how would have I figured, if I just had the equation, how would have I figured that out? I would have set the derivative equal to 0, right, and solved for the what we call the critical values. So that looks like it's about 1.4. Then let's go over some other ones. So this local maximum here, right? Think if I don't have the graph, all I can get are those x values. So a local maximum here would have been at about 1.1. Okay, this one here, there's a local minimum, right? Tangent's horizontal. And again, I don't know, if I was just doing this algebraically, I wouldn't know if it's a max or min, but really in this case, I don't even worry about it. I just substitute in the values. So the minimum there looks to be about negative, I would say 0.1. Or, oh, I should put 0.1. Negative 0.1. And over here, now let's look at the endpoints. So the endpoint over here at -6 is 0. And the endpoint over here is, looks like it's about negative 0.5. So what I need to do is, now that I've gotten all those values, I've got a y value here of 0, a y value here of 1.1, a y value here of -0.1, a y value here of 1.4, a y value here of -0.5. All I'm looking for is the highest y value and the lowest y value. Now, what I should do really is when I do this, I should be putting in all the x values of the key points left to right. So I've got one at -6, whoops, -6. Then there's another value at -5, right here. then there's another value at -2, and then there's another value at 1, and then there's another one at 2. Okay, and that gives me all of the key x values. So what are those x values? I have the x value at the left end of the interval. Then I have in here are all of the x values where I had a max or min. Okay, where a local maximum or minimum, where the tangent slope was 0. Okay, and then I have an x value at the right. And then what I do is I put in all of the y values. Okay, so what are all of the y values? Well, I should move this back here. The y values for -6, it was 0. For -5, it was 1.1. For -2, it was -0.1. For 1, x equals 1, it was 1.4. And for 2, it was -0.5. Okay, so those are, again, those are all the ordered pairs. So if I was to just show them like so, separate them out so you can see them a little bit more clearly. Okay, so those are your ordered pairs stacked vertically. So what am I looking for here? I have, again, my left point. I have all the interior points that have local maximums or minimums. They have their corresponding y values. And then I have the right endpoint. So I have those. Now what I'm doing is I just go through that chart and I look for what's the greatest y value. That's my absolute maximum. If I look across there, it looks like it's 1.4 is the greatest y value. Now what's my least y value? 0, 1.1, -0.1, -0.5. So right here, that is, this one here is our absolute max. So on this side over here, that's the absolute extreme value or absolute maximum on this side. And then over here, this is the one is the absolute minimum. Okay, right? The absolute minimum is -5. The absolute maximum is 1.4. And when we say absolute mins and max, we refer to the y value. You can add in the x value if you want, but you would say the absolute maximum of this graph is 1.4. It means the highest y value is 1.4. The absolute minimum is -0.5. And I can add on, it occurs at x equals 2. Okay, folks, so the whole idea for absolute extrema in an interval is what's the y value at the endpoints and what are the y values at any point in time where you can get maximums or minimums through calculus. So a tangent slope of 0. All right, so hopefully that helped in terms of you understanding that in a conceptual way.